Problem number 1. Jerry is 50 inches tall and is growing at a rate of 1/24 inch per month. So he's 50 inches to start out with, and he's growing at a rate of 1/24 additional inches every month. And that means for 1 month he'll grow 1/24. For 2 months he'll grow 2/24. For 3 months 3/24. So it's the number of months times 1/24. And that is a formula that will give you Jerry's height any number of months away from today. Adam, on the other hand, is 47 inches tall, and he is growing at a rate of 1/8 inch per month. Again, that's 1/8 inch times the number of months that he grows from today, and we'll add that on to the 47 that he currently is. If they continue to grow at these rates for the next 4 years, in how many months will they be the same height? Well, if the first formula gives you Jerry's height and the second formula gives you Adam's height, well, when we want to find out when they are the same height, we'll set the two equal to each other. And now we have an equation that we can solve for m. From here we can do the algebra, and we would like to isolate m. I'm going to select the right side, since 1/8 m is actually more than 1/24 m. 1/8 m is equal to 3/24 m. So I'm going to subtract the 1/24 from both sides. And when I do that, I get 50 is equal to 47 plus 2/24 m. And 2/24 m is really just 1/12 m. At this point I can subtract the 47 from both sides, and I'm left with 3 is equal to 1/12 m. When I multiply both sides by 12, I get that 36 is equal to m, and so my answer would be C. Now, it may be easiest to solve this problem using straight algebra, but if I were going to use my calculator, I would of course need to know how to create those, or to construct those two formulas or those two functions for Jerry's and Adam's heights according to months. And for Jerry, I would put it into y1, 50 plus 1 over 24x. We can't use m as a variable, but we can use x. And Adam's I would put in as 47 plus 1 divided by 8 times x. Now, one piece of information that's going to be helpful to me in solving with the calculator or graphing on the calculator is the fact that they're going to grow this way for 4 years. And 4 years is another 48 months. So if I just looked at the first formula for Jerry and made m equal to 48, then 48 over 24 would be 2. At most, Jerry is going to grow 2 inches over the next 4 years. And for Adam, 48, if m were equal to 48, 48 divided by 8 would be 6. At most, Adam is going to grow 6 inches over the next 4 years. So Jerry's height will be somewhere between 50 and 52 inches, whereas Adam's will be somewhere between 47 and 53 inches. And the total number of months will be somewhere between 0 and 48. So that helps me to set up my window to get a good window on this. The number of months is our x variable. And so I set that from 0 to 48 because they will grow this way for the next 4 years by 8. And the minimum height would be 47 and the maximum height would be 53. So when I go to graph at this point, I should have a very good graph. And going over the graph, I can see clearly where the intersection point is. That is where they both have the same height. So what I just went through is how we could use the information in the problem to get a good window to graph. You may not use that with this problem, but it may be helpful in another one. Finally then, to find the point of intersection, we go second, calc, intersect. We OK the first curve, we OK the second curve, we guess, just hit enter, and it gives you that x equals 36 when y is equal to 51.5. And so this is another way that we could have solved this problem.